tonight. Start off with a shout out to all of you that are meeting us from all over the country today. We had registrations from every state and territory and also from every sector as well. So thank you all for joining us here tonight. Really excited to be talking about one of my favourite topics, that being mathematics. I think I started to really passionately enjoy mathematics when I was at university studying science, and I started to learn about statistics, and that started a great love affair with statistics that really has lasted my whole life and will continue to last. So really happy to be sharing this with you here today. So if you have any questions at all throughout this webinar, please feel free to put them into our Q&A box. So there's a separate Q&A box from the chat box. Jump in and say hello to us on the chat. We'd love to hear from you there and let us know where you're coming in from today. But if you put any questions that you've got into the Q&A box, we can answer those as we go. We've got Dr. Pauline Ho joining us today on the chat box, which is great to have her there, and she'll also be presenting on Thinking Maths today as well. So fantastic to have you all here tonight. So just drop into the chat box where you're joining us from tonight. We'd love to know. So we'll start off, and I'll acknowledge the lands that I'm standing on here. So I'm acknowledging the traditional custodians of the land. I'm here in Melbourne, so the elders of the Wurundjeri people of the Kulin Nation, and pay my respects to elders past, present and emerging. And this is very meaningful for me. I've been fortunate to work with Aboriginal and Torres Strait Islander peoples throughout my career. They were actually the ones, I had two Aboriginal and Torres Strait Islander students that were the ones that catalyzed my career into education. So it's very meaningful to me and great to have you all here meeting from all over Australia. I can see we've got some people from Bass Coast. We've got Emily from Melbourne and Leonie from New South Wales as well. Thanks everyone for joining us and popping that into the chat. Really great to know where you're joining us from here today. So this is an outline of what we'll be covering today. So the first topic is really focused in on what does evidence tell us about the effectiveness of different ways to teach mathematics. So if we look at all the evidence all together, there are some things that we can do that practically we know will help our students in learning mathematics. We'll then be going through and looking at our evidence ecosystem, which is where we talk about how we position you as educators in the centre of all our work and the centre of all evidence-informed practice. Then excitingly, we've got Dr. Pauline Ho joining us, who's on the chat box as well, and I'll be handing the mic over to her at that time to talk about the Thinking Maths results. And these are results from a randomised control trial that were just published last Wednesday. So some very exciting news from that. We'll then be looking at more generally and more broadly, what does evidence tell us about effective approaches within the classroom? And we'll be having a look at our live teaching and learning toolkit, which was also recently updated at that stage as well. We'll then be talking a little bit about measuring maths outcomes and then questions as well. But as I said at the start, we have, you're able to ask questions throughout, and please use the Q&A box to do that. Fantastic. So I thought we'd start off with a quiz. Who doesn't love a quiz on a Tuesday night? And we'll just be activating a poll that you can be part of. So that should be coming up on your screen now. So please vote. We've got 3 questions there, and I'll bring the questions up as well. You've got feedback on how students complete a task is more effective than general praise. Great, the votes are coming in for that. So we've got true or false. Excellent. 57% of you have voted for that. Oh, almost 100%, great. And the next question is, calculators should not be used within the classroom. And that'll be coming up once you finish that first one. And the third one is around manipulatives leading students to have a reduced conceptual understanding of mathematics. All right, great. Well, what we can do, we can have a look at that first question because I can see all the answers are in now. And you're saying that feedback on how students complete a task is more effective than yep, and you're right, true. So we had everyone come back with true. It is much more effective, and we'll be going through tonight specifically around what are the ways you can structure your feedback to be even more effective within the mathematics classroom. We know this from the work of Carol Dweck and John Hattie and Black and William as well. We know that feedback can be incredibly powerful. In fact, the EEF have just released a new report that looks at the Black and William procedure and in giving back feedback, and they found that it gains up to 2 months of learning progress on that. So that's fantastic. All right, calculators should not be used within the classroom. So how did we go within that question? So what they found there is that calculators don't generally harm learners, and it doesn't harm their ability in mental calculation or in pencil paper skills. In fact, studies have shown that calculators can actually have a positive impact, not only on mental calculation skills, but also on problem solving and attitudes towards mathematics. And we know that attitudes towards mathematics can be really essential, and we'll be going through a couple of slides on mathematics anxiety tonight, which is really specifically and discretely associated with mathematics rather than anxiety in general. And it can have a positive benefit on that as well. So no, calculators are fine. Of course, we don't want our students being completely dependent on them, but they are used also, as we know, within the workplace to calculate. Manipulatives. So using manipulatives, will that lead to students having reduced conceptual understanding of mathematics? Okay, yeah, everyone right now, I can see what's happening. Just write into the chat box if it's true or false to manipulatives leading to students having a reduced conceptual understanding in mathematics. That would be great. Great. Yeah, false. You guys know, false. Yep. It's false. Can be really beneficial for increasing students' conceptual understanding. It's a learning step and a scaffolding that can be removed later on. Great. Thanks, guys. Thanks for finding a workaround. Tell you're all teachers thinking on your feet. Spectacular. All right. So into the next part. Fantastic. What we're looking at here are 8 evidence-based recommendations when thinking about mathematics. So the first one really is talking about essential that we know where our student is at, and we can do that through assessment, both formative and summative, and then use that assessment to provide feedback to the students. The second is what you all answered false to, which was correct, is that manipulables and representations can be very useful for helping our students to understand mathematical concepts, which can be quite difficult sometimes, especially in the primary years, to understand, and can help them and advance them in their learning. And then teaching strategies for problem solving is another approach that we can use. So enabling a rich network of mathematical knowledge to develop, developing independence and motivation. So that's really around the metacognitive aspects of learning. Also using tasks and resources to challenge and support the learner as where they're at. Then thinking about using structured approaches. So then that's thinking about, are there any approaches that we know if they work or not? And that's when Pauline will be talking about the results for thinking maths in that part there. And then thinking about, are there ways that we can help our students make that successful transition between primary and secondary school? And I know that can be difficult across all the subjects, but thinking specifically within mathematics for that. All right, great, let's jump straight in. So if we're using assessment to build on the learner's existing knowledge, what does that actually mean? Well, we know that assessment really provides us, it's assessment for learning, it provides us with deep and rich information about what our students can and cannot do, and what they know and what they don't know as well. Also can provide us with knowledge of misconceptions. And misconceptions are defined as a systematic pattern of error. If you're in Victoria, there's some lovely, we'll send around links. This is accessible for everyone, not just in Victoria as well, but some lovely materials that have been developed up around common students' misconceptions in mathematics, and then resources on how to help your students move past that. Developed up by Di Seaman out of Deakin University, was fantastic. So how can we provide effective feedback? Well, it's the same as in every area. It's really being specific, it's being accurate and clear, not providing too much feedback, and giving just that right amount so that the student will know what is the next step that they need to make. So letting them know where they've gone right, what needs improvement, and really focusing in on that, and not focusing in so much on praise or around so much the person. We know that that's the least effective area to target feedback to. We'll be talking feedback in depth in a webinar in a couple of weeks as well. So, and that will really go into in depth the key areas that you can target feedback to. All right, using manipulatives and representatives. Very exciting. So manipulative, which is a physical object, while representation is such as a number or a line graph. So they're really thought of as a temporary scaffold to help students learn a particular concept, and should be removed once independence is shown, and you'll know that based on what that they can demonstrate that they actually understand a particular concept. So we need there to be clear links as to why you're introducing the manipulative at that particular point. So make clear links as to what the manipulative represents in a mathematical concept, rather than just having the students engage with the materials. And then again, just be mindful as to when's the best time to remove the manipulatives. And down the bottom too, you'll see access to the reports that this material is being based off throughout, and there'll be clickable links, and we'll send this out at the end of this as well. So important to try and teach problem-solving skills. So problem-solving skills in general, and these can only really be, you can only really learn problem-solving fully when you don't know the answer to the problem. That's really the whole discipline of, sorry, I'll go back to my career as a scientist as well. It's really in exploring and trying to identify what could be a possible path forward. So important to do that, but important to scaffold the students too. So using worked examples before that point, and I'll take you through an example of what worked examples can look like as well. So using work examples allows the students to compare different procedures and different strategies, and it encourages them to monitor and communicate and reflect on why they're using a particular strategy at a particular point in time, which is one of the key learnings in maths. So here's an example of how we can teach problems, which is an example of problem pairs from Greg Ashman, who's a maths teacher down here in Victoria, and I've linked to his blog there. So a worked example, it's, as you can see, it's a problem that has already been solved for the learner with every step fully explained and clearly shown. So what they've found is that novice learners who are given worked examples perform a lot better at subsequent tests given similar questions. This is because they've learnt as much as they can, and we're not placing an unnecessary burden on their working memory, and we're helping them to transfer it into their longer term memory. So we also want to help our learners to develop a rich network of mathematical knowledge. So we need them to make links between mathematical facts, procedures, concepts, and ensure that they learn and develop a fluent recall of number facts, okay? So, and teach them to choose between the different mathematical strategies, as we saw before for using problem pairs, for example, and also use and recognise different mathematical structures. So, within this, we know that it is fine, as we found out in the quiz, and I think you all answered yes as well, that it's fine for students to use calculators, that it doesn't reduce their ability in mental or pen and paper calculation skills, and it can also help attitudes towards mathematics. So the aim here is not to create dependency upon the calculator, but rather to help those learners really become self-regulatory in their use of calculators, so making better use but less of the calculators over time. So here's an example of teaching learners how to recognise and use mathematical structure. So sometimes a common misconception is that the equal sign means to calculate rather than equivalence. So a way that you could write that on the board would be to write it, as you can see at the bottom of the slide, which is just saying the equal sign, and then if you write which is the same as, and that really teaches students that we're not just talking about calculation for an equal sign, it also can mean equivalence, which, as we know, is really important for algebra and the fun that we can have with triple derivatives when we get to university. Sorry, that was just a bit of a I remember doing triple derivatives. They were a lot of fun. As a little aside there. Okay, moving on from triple derivatives. And negative triple derivatives were the best fun. Is there anyone else out there? I should check on the chat if anyone's feeling the love for negative triple derivatives. No, no one. No, fair enough. No, gotcha. Sorry, I'm going to lower the really super nerdy jokes. All right, so what are we trying to do? We're really trying to help develop, and throughout every subject, specifically tonight we're talking about maths, we're talking about how can we help foster that independence and motivation within our students, which they'll need not just for our classrooms, but for life. Definitely not love the smiley face. Okay, I've got to stop being distracted by the chat, but you guys are fun. Learners need to develop their metacognition. So metacognition, thinking about thinking, it's the ability to plan, monitor and evaluate, okay? I heard Sir Kevin Collins, which is the head of the EEF in London, describe it as a map for learning. And I like that. And it had like the peaks and troughs of planning and regulating, and that's the best description I heard. So I always use it, and I don't think he minds. All right, teachers need to model metacognition, and so a simple way of doing that is self-instruction. So while you're doing the maths question on the board, which may feel a bit strange, but probably a lot of primary teachers are doing this already, and I encourage secondary teachers to do it as well, is to self-verbalise why you're choosing a particular approach and why you're going that way. So you've got to, if you verbalise those steps, it's an effect size of 0.62 is self-verbalising and saying it out loud to your students. And then that way you can encourage them to be thinking about, okay, so the first step is this, and then the second step is this, and then if you're saying it, they can be learning it. So we're going to be covering that in more detail, metacognition, self-regulation, on the 16th of October, if you want to learn more about the wonders that is metacognition and self-regulation. It's something I'm quite passionate about, because I think it's quite untouched and sometimes a bit theoretical, and I don't like theoretical. I like things to be quite practical for you guys, because I am a teacher. I'm still a registered teacher, and so it's got to be practical. All right. So here is a set of questions that I was just talking about before that you can say out loud. So this is a scaffold that you can provide, that you can say out loud and also provide to your students, and ask them to actually answer these questions. So what's the problem asking? Have I ever seen a mathematical problem like this before? And if you've taught them in problem pairs, well, then they'll be saying, yes, I remember you taught us that a couple of weeks ago, miss. And then you'll say, what approaches to solving did we try then, and were we successful? Great question. Could I represent the problem with a diagram or graph? I love graphs, so that could be an absolute win. Does my answer make sense when I reread the problem? And do I need more help or information to solve this problem? Because we know that help seeking can be difficult for some students. I know that I've worked with students that found it difficult to actually ask for help. These are super competent students and aren't really used to asking it, and that we know is an essential skill for not just school but for life as well, is to say, look, I need help, guys. I really need help in trying to solve this problem. And then where could I find this information as well? So that's just a scaffold of questions that you can use for your students and for yourself as well in verbalising. So then now looking at specifically at mathematics anxiety, and I know this has been a popular topic of late that I've seen represented, and so it's not a general anxiety, it's really just specifically about mathematics. And what it does is that, and I think we've all seen students do this, and we've probably all done it ourselves, probably maybe not with maths, but maybe with other subjects, is that we can get into a state where we shut down, we're overloading our working memory. And our working memory, a nice definition of that is just what we're conscious of at any one time. So there's a nice piece there for the Centre of Education Statistics and Evaluation out of New South Wales on cognitive load theory, if you want to read more about that, which I'm a bit fascinated by the way the Brown works. So I read all of that and dragged that point from there. So unfortunately, it tends to increase with age, but it can be perceived in children as young, in the years of 4, 5 and 6. So that's around your 10, 11 and 12-year-olds. So first step is teachers can look out for learners avoiding mathematics or displaying signs of anxiety. So freezing, fidgeting, and then that way you can use your knowledge and professional judgment to help overcome their anxiety. And then I thought, who better to include than the wonderful Eddie Wu, who I was fortunate to meet not so long ago, a couple months ago. I'll just give you a second to read this slide. So yeah, sometimes it'll take me a whole month of working with students, actually telling them it's okay to be slow with mathematics. The important thing in mathematics is not speed, it's the ability to slow down and ask the right questions. It's okay to make mistakes. Actually, mistakes are so wonderful, because if you make a mistake, you actually learn from it, and that's the most important thing. So helping my students grapple with that and not judging them, and helping to see that they're accepted in the classroom and that it's safe. It's really important to let students know you're not going to jump on them and you're not going to make them feel belittled because they can't get the answer. And so, except if you're on a time test, fair enough. Definitely not so useful with a time test, good point, but useful in every day. And I think if we can reduce it every day within the classroom, then when they are within a time test situation, then they will cope better within that, is my feedback. And great question there. I just glanced at the chat box. Thank you. And another tip for, I guess, with getting students that maybe have anxiety around time tests is to have them do the time tests more regularly so that they get used to that and they get better at it, which is all of us, isn't it? If we're repetitively doing something, we will create neurons in the right direction that things become easier and easier to us and they're no longer stressful because of repetition. So that would be my advice around a time test situation. Great question. All right, so using tasks and resources to challenge and support the learner. So assess the learner's strengths and weaknesses to inform your selection of tasks. And then discuss and compare different solutions. So you can get a class discussion going and then have the students present their different approaches. And then that way, and so for example, here's one here that was being provided, and different students provided different ways of doing it. And so by the students looking and seeing that there are different ways to approach it, they're actually learning a lot more when they have to do it physically up on the board than if we were to explain it to them. So that's a useful point. And there's an example there. Beautiful. And then what you can do too is then point out to the students which way do you think is more efficient to execute mentally? What is the easiest way for us to do this? And then that will get them into really try to think about what are different ways that we can answer this question, and then what's the most effective way, which is really where we want our students to be thinking about. Okay, there are lots of different ways we can solve a problem, but what is some of the more effective ways, because that will get them to do better in those time tests as well. All right, and then if we're finding that our approaches to mathematics aren't producing the results that we want, then we can think about, are there any approaches that we know that are structured and that are useful and that other schools have tried and have produced positive results? Needs to be evidence-based, carefully planned, and it takes a lot of work. And so I'll talk you through our conceptual models around implementing a change like that within the classroom and what is involved in that, which no doubt you're all aware of, but useful to think about how to implement that type of approach. So that all starts off with which is our impact evaluation cycle, which is a way to structure change within your school to helpfully point it towards improvement rather than just change. It's a school improvement cycle for school leaders and an action research cycle for all the teachers in the audience. And how many teachers that we have, I'll see come up on the chat. Type it teacher into the teacher box if you're a teacher. I know that we have some here, and leader in if you're a leader. And I'll just give me a feel for who we have here. Awesome. Teacher, leader. Nice. And then the wider evidence chain is where the policymakers and the policymakers are living. So I'm saying you yourselves, and it looks like we've got a pretty lovely spread of teachers and leaders, two of the best groups of people in the world as far as I'm concerned. You teacher leaders, we put you in the centre of that diagram because we believe that no evidence-based practice is going to occur without you leading it. And the second is that by you measuring your impact the impact that you're having through making that change, whether it be a change in mathematics or a change in a different thing. We believe that those are the research questions that should be being answered by the wider evidence chain and researchers, and then that should be shared back in practical ways. And our third point is that both those cycles are dependent on one another. Yeah, I hear what you're saying, evidence-informed or evidence-based. And I sometimes change between the two, but I'm more an evidence-informed person, just in that language. Good question. So what are common barriers to engaging with evidence? Shortage of time to engage with research. I was a secondary teacher. I was in charge of a subject area as well, so sometimes no time for lunch, let alone engage with research. But I'm not encouraging you to go without lunch. I'm saying teachers and leaders want you to eat lunch, because I know the hours that you work. Then there's an overload of information to process, and then there's insufficient contextual information really to inform that practice. So this is what we're saying here: in order for research to be useful to you, and that's in order for you to be able to implement it within your classroom, we're saying first it needs to be produced, then it needs to be synthesised. We see this in the work of Mazzano, in the work of Hattie, in the work of the Teaching and Learning Toolkit, which we'll be jumping onto later. And then we're saying it needs to be transformed. So there needs to be additional information added, such as cost to implement what's a month's worth of learning progress, etc. And then we need engagement. That's what we're doing here tonight, and that's what my role is, helping people to engage with evidence, and then you implement it and you do the tricky work, and then you tell me how it's gone. And people have told me some wonderful things that are happening. So the impact evaluation cycle, that's the way we structure a change. We have a look at that now. Does anyone want to tell me about a challenge that they're facing in their school? And I can structure the impact evaluation cycle around that challenge. So does anyone in there, I'll just wait for the chat box. Does anyone have a challenge that you're facing in your school now? And that's our impetus. So it can be something like having trouble with lifting, the Peter effect. The Peter effect, wait, does someone want to, lack of consistency across the school? Is the lack of consistency across the school to do with numeracy outcomes? Because I think that's a good one. Lack of, yeah, okay, great. All right, fantastic. All right, yep. Okay, all right, well, I'm going to go with lack of consistency across the school. I really like that as a big, massive issue, and it's actually an issue for all of Australia, because we know that our classroom to classroom variability is much higher than our school to school variability. So that's one of my pet favourite things. So I'm going to jump on that as our impetus. So our impetus is that we've got a wide variety of practices and a lack of consistency across the school, and I'll limit it to in teaching in general. So great impetus. So our awareness is going to say to us, well, what do we know about a lack of consistency and ways that we can fix a lack of consistency? So we might look into things like professional learning communities and having our teachers engage with that, having an open classroom situation shared, co-planning, co-teaching, also having walkthroughs. We know that those are all things that can help us with a lack of consistency across our schools in regards to different practice. And then we're going to say, okay, that's good. There's a whole lot of things that we could do, but what's practical for our setting, for our teachers, and how will we actually know what is best practice as well, what's occurring within our classroom? So we could do analysis looking at various different best practices across the school, and then look to scale that up through the various different ways I was talking about, which was implementing professional learning communities. I know some that have been implemented very well here in Victoria in Keilor Views Primary by Helen Butler's been doing a lovely job of that with the Teaching and Learning Toolkit as well, and looking at how they can implement evidence-based approaches consistently across the school and using PLCs. And it's a topic I'm fascinated with, and it's incredibly exciting. And then you're going to adopt and adapt. So you're going to say, okay, those PLCs will be useful to our whole, we might start on a smaller scale and then work it up across the whole school, or we might try a whole school approach straight away, but then look at what impact is that actually having. And then we'll be adapting based on what each different classroom needs as well. And then we'll be acting, evaluating, adjusting in a mini implementation cycle to try find out what effect that is actually happening on the students. So if we chop that in half, and then we'll make the difficult decision to embed or admit. But since we're doing something around scaling up in a school good practice, it will most likely, we'll find out what works and we'll scale that up more, and we'll find out practices that don't work so well and we'll try and reduce those over time. Yes, we haven't, yes, good questions there. So intervention of the program and then evaluation process. So this is evidence-informed decision-making. Generally, so integrating, and I'm all about professional expertise, having been the teacher, and with the best external evidence from research to improve the quality of practice, not about prescribing what goes on from a position of unchallenged authority. And so when we're thinking about that, we can think about evidence being thought of existing within a hierarchy. And this is our hierarchy of evidence here. And what we've placed at the top is systematic reviews. So they're reviews that meta-analysis that have incorporated lots of different studies into them. Sitting down from that, and level 2, which is what we'll just be talking about in a second, which is the large-scale randomised controlled trials that we're running here in Australia in some mathematics areas. We've run 2 mathematics areas, which we'll be covering. And then we're not saying that really it's not helpful to do that type of approach for every single process that you're rolling out in a school. Sometimes it's really useful to do a case study. I've done case studies myself, and they're really useful alongside randomised control trials, and also just useful to try quantify and qualify and also codify what is happening at the school. So what does the good practice actually look like, and figure that out. All right, so if we jump now to looking at what we do, so we build evidence, and that's Pauline's job, and she's on the chat box tonight, and she'll be jumping on the mic in a second. So we've got 3 randomised controlled trials, one that has been completed, and one on the next slide will take you through exactly specifics around that. We've got the Teaching and Learning Toolkit, which we'll be going through, and our tailored toolkit specifically, which is a focus of tonight's, which is mapping policy to progress. Do we have anyone from Victoria here? Everyone enter your state into the chat box for me. And then we've got, thank you, getting out and supporting events like we're doing today. All right, so we got WA, New South Wales, Queensland, awesome. Awesome, I taught in Queensland, so I do have a bit of a bias towards Queensland, but you're all great. Okay, what I'm going to do now is hand over to Pauline, and she's going to take us through the progress with the Learning Impact Fund currently.
Hello everybody, so this is just the web page that we have on the Learning Impact Fund on our web page, Evidence for Learning. And as you can see, there are 4 exciting randomized controlled trials that we are currently running with different evaluators as well as program developers. One of which we'll be going right into today is the Thinking Math one. As you can see, excitedly, we have completed the project, and it has the indicators now being presented on the cost, security, and months of impact. So if we go to the next slide. Oops, I think Tanya would, yep, that's good. This is really what we are measuring, the program logic. The Thinking Maths program, just to give a bit of context around the Thinking Maths program, it is a program to boost teachers' pedagogical content knowledge. And the teachers of concern here are the middle school teachers from years 5 to 10. It's designed to really build a PCK to engage students' mathematical learning. The key strategies the program uses is an inquiry-based active learning approach that focuses on metacognitive strategies such as effective questioning techniques, and to really build that into designing of quality tasks and problem sums that can really engage students in deep mathematical thinking, as well as getting their process about thinking about math thinking. The professional learning program is conducted 5 times across 3 terms, and the teachers actually are intended to bring back those strategies that they learned in the PL session back into the classroom, implement it with their students, and coming back to the next PL session to talk about their challenges and whether it worked for them or not. So as you can see from this program logic, they measure both, the evaluators measure both the teacher outcomes as well as the student outcomes. In terms of teacher outcomes, 3 measures were being measured. So the PCK, which is the pedagogical content knowledge, professional identity, and self-efficacy, as well as their beliefs about mathematical learning. And the next measure is effective teacher practices. So this part really looks into how students evaluate their teachers' practices and seeing how they have been asking effective questions that help them through the maths problems. And then in terms of student outcomes, the evaluation looked at 3 measures. One, looking at mathematical anxiety and low self-concept. And as Tanya has brought up earlier, there's evidence to show that mathematical anxiety does increases as students grow older. So as we can see from this study, is quite, and not surprisingly, that the secondary school students do get more anxious from having the new intervention, which is thinking math, being implemented on them. We didn't really go right into what the causes or the reasons are for the increased anxiety, but this is certainly something up for discussion. So cognitive engagement is the next one that we measured as far as metacognitive strategies. Rather than going right into the details of the mechanics of the evaluation, I thought it'd be great to just look at the data that is being presented on each of these measures. So what we can see is that we have very high effect sizes on, especially on the pedagogical content knowledge, which is 0.70, and that translates to almost like a 9-month learning months of learning impact, as well as it's not reflected here, but what we can see is that for primary school teachers, there's a 2 months progress, and for secondary school teachers, there is a 2 months loss of learning. So there's a gap between the primary and secondary learning in terms of implementing this program. If we look at metacognitive strategies, there's something that tells us that this program did not really effectively build students' metacognitive strategies. That is a minus 0.02 on the scores. And that is really something that is not surprising to us, but it's really worth investigating further, because what we can see is that the professional learning programs does have a huge impact on teacher outcomes in terms of their pedagogical content knowledge, and that's really strong, but the translation into student outcomes is not quite there. As you can see across the 3 measures on student outcomes, the measures are really lower than what we see on the teacher outcomes. So if we go on to the next slide, this is really the kind of summary table that we have in all of our reports to help educators get a sense of what the evaluation is telling us in one glance. So what you see is that we have categorized students, and evaluation does analyze students across the different subgroups. One being all students, means looking at the evaluation outcomes across year 5 to year 10, whether the program works for them. And as you can see, the effect size is 0.05, and that translates to a +1 month progress. So we're saying there's a 1 month progress of this program for all students. However, there is no evidence in terms of statistical significance. So we really want to caution educators in terms of understanding this finding, that it may be something that occurred by chance because the significance is really high. So it's not that great in terms of significance statistically. What we can see is in terms of the padlocks in the 4th column, those are telling us, 4 padlocks is telling us that this entire evaluation is built on very high security. So meaning to say the design trial is really strong. And what we can say of the findings is that it's something that we can trust because it's 4 padlocks out of 5, which is based on a very strong methodology behind it, which we won't go into today. And we also have the indicator of cost rating, which gives educators the opportunity to make an informed decision of whether this intervention is something that is cost effective for their schools or their settings. So it's a $1, which doesn't mean it's $1, $1 sign. Cost rating meaning to say it's a very low cost intervention. So there's something to consider as well. Well, I won't go much into details, but if you look at the different subgroups, you can definitely see a gap between the primary and secondary outcomes. So we've got a +2 months of learning progress for primary schools, but a -2 for secondary schools. But we're saying primary years 5 to 7 because South Australian's system for primary schools is up to year 7 for primary school and starts at year 8 for secondary schools. And there is definitely a bit of a benefit for the proxy for disadvantaged students. So students who are school card holders have a +1 month learning progress. If you have any questions, do pop it into the chat box or even the Q&A. Tanya is managing that space. In the next slide. So we just want to take you through some of the findings, and we do have a session that is really specifically on the Thinking Math program as well as the evaluation results in the very last webinar series that we are holding. That will be on the 13th of November. So if you're really interested in some of these findings as well, how it translates to practice or policy settings, that is the platform where we will really talk more about that. But very quickly, it's saying that this program has a very small positive effect on years 5 to 10 students' math achievement. But again, I say this is not statistically significant, so we need to take this finding really cautiously. It has more positive effect in primary context than secondary context. So a lot of programs in terms of professional learning does show more impact on primary rather than secondary, and that's something that we really need to investigate. It does have largest impact on PCK, which we talk about, and lesser impact on students' learning. And again, this is a professional learning program. It does stretch. It does take a long stretch to get to the impact on student learning outcomes. And there are barriers in terms of implementing this program in secondary schools because of timetabled lessons, common tests, set textbooks, as well as the lack of time to plan. In the next slide, I think the next slide is going back to Tanya. And Tanya will talk more about the transition between some strategies to help bridge the gap between primary and secondary schools.
Thanks so much, Pauline. Great to have you here.
Thank you.
Pleasure. So yeah, okay, so that was really focused in on, and it's a really good example about something that has worked well in the primary setting, not so well in the secondary setting. We do know also that there were complications around implementation around that program in the secondary setting, so we can't be sure, and it's also had a reduced amount of time in the secondary setting. I know it was only 3 hours a week, so harder to measure an impact of that in the secondary section. But what it does tell us is that we know that our students find it difficult in that transition from primary into secondary. We know that it is a big change for them. There's not that much evidence about things that we can do. It's more about things that aren't helpful. So we know that setting or streaming, so basing the students into a certain mathematics class based on their prior achievement. We know that that's definitely not helpful, especially for the middle and the lower quartiles of our, so the middle 50% and the lower 25% of our students can really, that can detrimentally affect their learning. So we know that that's not a positive way forward. So these are the different strategies that we've been talking about today, and we know that they can have a significant difference and impact on our students' learning. And we're just going to go to the live site now and just have a look around. So that should be sharing with you now, the live site. We're just going to have a look at the tailored toolkits that I was mentioning. That's why I was asking you what states you were from. We're going to have a look at the tailored toolkits, so approaches by organisation. And you can see that dependent on what state or territory you're from. So I saw that there were some people from Queensland, and I know if you're in Queensland and government schools, that the National School Improvement Tool is a place that would be interesting to you, for you to go and have a look, because I know that your state has built their system around that. It is a very nice tool. If you're from Victoria, we've mapped to FISO, and we're just about to map in the next couple of weeks to the HITS and also to your practice principles, which is exciting to be working, really exciting to be working with the Victorian department. I saw some of you are from New South Wales as well. So if you're from New South Wales, we've mapped to your school excellence framework, so you can go and have a look at that. For tonight, and have I left off anyone? Or WA, also I know that you have used the National School Improvement Tool as well. So no one can see the live link. Oh, sorry everyone. Let's have another look. I'll have another go. Thanks everyone for letting me know. Sorry, can you see it now? Yeah, I think you can see it now, yes. Thanks for letting me know, guys. Okay, approaches by organisation. So I was talking about the different ones that are relevant to you. Also, New South Wales Department of Education. I won't say them all again, but you can find them all here. Australian Council for Educational Research. Tonight, a good one I thought to look at was the Australian Association of Mathematics Teachers, so AAMT, and we mapped it there to the Standards for Excellence in Teaching Mathematics. So, for example, the learning environment, these are ones that are relevant to that specific strand. And we've also mapped to the AITSL's professional standard for principals, and then Australia's, and then for principals, and then the professional standards for teachers. So that's all there for you as well if you ever want to enter the evidence base through a slightly different way. And we've just launched our new site this week, which also I have to do just a quick little jump on, but I need to be super quick. We've launched our new site just on Friday, and you'll notice some of the numbers have moved up and down. So metacognition and self-regulation's gone down by 1 month. But what's really exciting, we now, if any of you have been on the site before, we now got our references online, and you can link out straight out to the relevant reports from that. And you've got the mean weighted effect size there. Yeah, anyway, it's glorious, and I love the new site. All right, we're going to jump back and wrap up in 5 seconds. All right, can you guys all see you can see my screen? Yep. You can see the PowerPoint? Yeah, beautiful. Thanks, guys. So I just walked you through that. I've just provided the links there. Measuring learning, important. I'm just going to wrap us up because we're right at the end. Different ways that we can measure our students' learning. That's just different ways. I just wanted to leave a couple minutes for questions. So feel free to type any questions into the Q&A. How did you measure increases in teachers? Oh, is that the question? How do you measure increases in teachers' practices? Is that practices? Oh, PKC. That's a great question, and I'm going to throw to Pauline to answer that one because that is her way. Pauline, how did you measure increases in teachers' professional content knowledge?
That is a great question. So I've got it here, and we measure it by looking whether at teachers providing timely feedback to students and if they use questioning to develop students' conceptual understanding. So this is their own perceptions based on the survey that they do, based on their own perceptions on a perception survey.
Yes.
But there are a couple of other questions as well.
Great. Thank you. Fantastic to have you in the room tonight. Now, are there any more questions before we wrap up? We've got like 2 minutes. Oh, thank you. I'm so glad you like the website. Thanks a lot. So glad. Thank you. Sorry, just reading the chat box there, everyone. All right, let's say good night. I'll just do my last slide. So if you want to find out more about our work, join our evidence-informed educator network. You get alerted to things a little bit sooner than everyone else, like this webinar series. Subscribe to our newsletter for updates. We often write things and then we draw from a whole range of international practices in pulling that newsletter together. And we always, it's always super fun. We always write a blog or do something fun in it as well, which we all love. Great. Such good feedback. Sorry, I'm distracted by the chat box. Follow us on Twitter if you'd like. I'm on Twitter as well. Feel free to follow me. I'll follow you back and we can have a chat. We're on Facebook as well, and any comments and feedback to me at Tanya Warner Evidence for Learning, or any questions that you have. We'll be sending a follow-up email with links and resources that we've talked about in this. I'm really glad that you found it useful. Our whole drive is that these are useful sessions to you, and I'm going to wrap up because it's exactly 7 o'clock. I'm really impressed with you all for coming out here tonight, and happy teaching and leading tomorrow. And yeah, good on you all for doing what you do.